Okay, the picture shows a beam which is slightly bent due to some weight kept on it or due to its own weight maybe. Though it's not directly in our syllabus of iit-jee, but it is not very far from the syllabus, the boundary of syllabus. So this type of questions those students may prepare who want to have some edge over other students. So this is bending beam. When the beam bends, there is a boundary shown by red here. This red layer you can say, and this is a red layer. So all the layers above this red one is slightly smaller than all the layers below this red layer. So if you consider this red layer to be of original length as the beam was when it was not bent, when it was straight, then all the layers above this red one are compressed, while those below the red layer is called neutral layer. The layer which is neither compressed nor stretched, it is called neutral. This is neutral. And if you see the cross section of this beam, and this red line shows the position of neutral layer. Neutral layer can be anywhere. In most cases, it will be in the middle. Fairly, most of the cases, when the cross section is of uniform shape, of a regular shape, this neutral layer is in the middle. So this red layer is a neutral layer. Neutral layer means its length is neither shortened nor elongated. And suppose the radius of this neutral layer is r, and the neutral layer is making theta angle at the center of the curvature. Consider one more layer below this neutral layer which is elongated a bit, and suppose its radius is r plus y. Then this yellow layer is elongated by some amount, and it has a strain in it, as change in length over length. So the length of yellow layer is r plus y theta. And originally, when this beam was straight, every layer was having the length of neutral layer. So r theta was the original length of every layer. So this is a strain y over r. So this yellow layer is strained by this amount y over r. And so therefore, strain is a stress over Young's modulus. So it must have some stress on it to get this strain. And if sigma is the stress, then a force must act on this yellow layer, that is sigma into dA, where dA is the area of this yellow layer. And similarly, if we consider other layers, they will all have force acting on them. The layers which are below the neutral layer, they will be stretched and they will be having a tensile force, while the layers above this neutral layer will be compressed, and therefore they will have a compression force, a compression stress. Okay, so suppose this cross section is of size B and D. This red line is a neutral layer. The position of this yellow layer, as shown in the figure, is suppose at a distance y from neutral layer, and its thickness is dy. And this circle dot is indicating, if someone is viewing this layer from this side, then this force, the direction of force will be towards the observer. The circle dot means the force acting on this yellow layer is towards the observer, that is towards us, supposing we are the observers. Then the force acting on this yellow layer here, that is sigma dA, and dA is the area of this small strip here. So its width is b, while its thickness is dy. And if we take a moment or torque of this force about this neutral layer, then that dm is torque acting on this layer with respect to this neutral layer. This is y into df, df into y. So this is the torque. And the total torque acting on the whole cross section about this neutral layer is integration of this from minus d by 2 to plus d by 2 from here to here. And sigma we can replace from here. It is y e by r. And if we solve, it comes out e by r bdq by 12. In short, we write bdq by 12 as capital I. So it is ei over r. So this is the formula we have. Bending moment, it's called m is bending moment, and it is e times I over r. So based on this formula, there are many questions in which questions regarding bending of beams are asked. So though this formula itself is not in the syllabus of iit-jee, but this is stress and strain, it is in the chapter of elasticity, so this formula can be derived very easily. Okay. In maths, we know that the radius of curvature is given by this expression. And since bending is very small in many cases, so dy by dx, that slope, the slope of this beam is very small as compared to 1. So we can neglect dy by dx as compared to 1. So this expression reduces to 1 over double derivative. This formula you must have studied in maths. So r is, you can use r as 1 over double derivative of y with respect to x. Okay, so on the basis of these two formulae, we'll see some questions one by one.